Okay, welcome to lecture 1 of Design 330, Spring 22, on week 3. And so the first thing I'm going to do is just a real quick comment on the submittals that I've seen so far. And this is the main thing that I see. Some people have left this out altogether. This is your material list. And many people copied exactly what I had put down and didn't finish it up. So the idea, I gave you an example. You actually need to do this for the driven gear and the driven gear blank. So this up here does not demonstrate that you understood the material because I gave you that. And so I left you an opportunity to do one down here. So please, if you have questions about that, get with me. I think it was just looking up information and filling this out. So this is for you that you have to fill out. And you're going to be adding more to this week, to your material list. And it's really key to what we're doing. And so please do those. I think it's a common issue this week. So that means I probably didn't explain it well enough, but somebody asked me during lab, and I will go over it again so that you can learn how to do that. Other than that, let's see what's up for this week. We're going to do shaft design now. Now the shaft that we're using is actually a hexagon, and there's many versions of the same one that could be used or made. So we're going to look on something called a tabulated drawing, but let's see what we're supposed to do. So watch your videos. I'll have a few more videos in there, not too many this week. Again, the expectation is that you remember how to do enough Inventor and enough AutoCAD to be able to do these. If you don't, you need to come to the labs or ask specific questions of the labs so that I can do demonstrations. But I'm not going to teach from the very beginning of Inventor. But if you have a question and you've watched the quick demos, for sure, just pipe up and I'll realize it's been a while. So not so bad. All right, so watch those videos. And then you've got drawing files to create again and design files. So design files are things like the IPTs, the inventor drawings, the Excel drawings, and now you're also going to do a design review file. So there's more than just drawing here. We're doing some design. Okay, so save all your stuff on the Google Drive, things like that. So here's what you're going to do. You're going to create things from this file. Okay, it says no preview available because it's an IPT. So of course you'll download it and open it in Inventor. That is the transfer shaft file. And it looks like this. Okay, so there we go. So you're going to work with this very simple design this week. And then you're going to make something that looks like this. Okay, you don't need this ring if you don't want. Okay, but front view, side view, isometric. They're at different scales. Your revision history, here's another table. And I'll be explaining what all those mean in another video. So you're going to make this, and you're actually going to, it's called tabulated, because you're going to represent many parts with this one little drawing. So you're going to make that, and then you're going to put in values into that table for the input shaft for both as designed, which would be like, what your design has to be, and as if somebody 3D printed it. Because 3D printing adds material to the design. And so you have to sort of like make adjustments for that. So there's an input shaft, the transfer shaft, that's the one between the two gear packs, and then the output shaft. So this is the one that's attached to the green gear, between the gear packs, and attached to the red gear. And I'll give you some information on those. And then we do want to talk about actually creating something that we could 3D print. And so that's called an STL file that we can open with a 3D printer and actually create. And it's an export. Pretty straightforward. From here, it's File, Export to a CAD format. And the one that we like to use for 3D printing is STL. And then there are some things to do to make sure that you're in the right units, all this kind of stuff, binary, big, and then you just save it somewhere. No, and I don't want to replace it because I've adjusted mine perfectly already. Okay, so you'll go ahead and save it. And again, I want one for the input shaft, the transfer shaft, and the output shaft. And then you can actually, you don't have to have a 3D printer to see what it'll look like. You can open it on an AutoCAD, Autodesk viewer, TrueView, or the or you can just look at their 3D viewer. And I'll give you more information on that. I'm just going over the what to do. So you've got a parametric file to work with, a tabulated drawing to make, some STL files, but I haven't given you any dimensions yet. My gosh, you're going to work together to figure out what the dimensions need to be. I have a video on that for you. So this is actually the first thing to do. Your annotated design tolerance review. You don't have to, but you could after you've made your drawing. Once you've made your drawing with your table and all that in it, you're going to want to go find what dimensions you actually need to use. And I've given you a sample here that you can go to see. Here's a step-by-step on how to do it. Now, you don't get to use my numbers. You have to use different numbers. And you'll make your own. Okay, so I've given you a thing to do on that. There's a discussion. Oh, I have to get out of student view to see it because it's not open yet. It's about something called gear backlash. So we're going to really study gears throughout this whole thing. We're going to keep coming back and learning about gears. And so we did some gear design and we found a center distance and all that kind of stuff. But there's another feature to gear design that's called gear backlash. And it might be important depending on, get rid of that, depending on your design and what you're doing with it. So I just want you to look up some information, Google gear backlash, find some examples of when backlash is good, you want backlash, or when it's bad, ooh, backlash is bad, and when it doesn't matter. Okay, so backlash is just a thing. It's a condition that occurs. And whether it's good or bad or doesn't matter depends on the design and the use and all that kind of stuff and how much there is. And then find a few examples or explanations of how to control backlash. If my design does have backlash and I want to get rid of it, how do I do that? Or if it doesn't have backlash and I want some, how do I get it in there? And then I want you, after you've figured this out a little bit, to use your gear set data drawing that you made last week and replot it, but increase the center distance 0.005 and then do it again at 0.001. This would be part of a design review. Okay, eventually. But we're going to just be working right now just to make sure that you can do it. And then just, kind of explain what you learned in this study. Now, this, I would hope, the explanation, I would hope would be a video recording. If you can't do a video recording showing your screen of what you've done, type it out. That'll be okay. But the goal is to get you used to speaking so that when you have to stand up in front of a boss or a colleague or a client, you've had some practice. And this is a much better place to do it for the first time than in front of the boss or a colleague or a client, right? This is just a really nice place to be able to do it. And, you look back and you go, oh, I didn't like that. Well, we don't care. It was just practice. Okay. Maybe you want to do it over again, but who cares? Okay. It's just practice, just practice, just practice. So that's your gear backlash discussion. What to do here. Whoops, wrong one. Oh, I didn't put the executive summary up. I'll get you that posting. Now, I noticed that a couple of people did not complete all their work and they took slides out. And that's a no-no. Okay? I need to see all the slides, even if you didn't get anything done. All right? So sometimes I say take them out. But on these executive summaries, you need to be, you can just say, I didn't do that one. I didn't do that one. I didn't do that one. Okay? So this is all just like we've done before. Okay, you're getting good at this one, I hope. Week 3, shaft design. Here's your tabulated shaft drawing. And I do want that in AutoCAD also. Okay, Inventor and AutoCAD. And I'd like you to actually use AutoCAD rather than just making it an Inventor and saving it to AutoCAD. I'd like to see those AutoCAD toolbars up there, because then I know that you're practicing it. And so if somebody needs a demo of how to do this in AutoCAD, just ask me, and I'll go ahead and do that during one of the lab sessions, and you'll have that. So there's a tabulated shaft drawing. There's STL export files. And then I'd like you to put an online viewer to present an image of each of the STL files that you've made. There are parametric design tables. Those are these. But for those of you who remember your Design 328 and Design 310, I know that you've been able to link to Excel and XMLs. And so if you'd like to show and remember your skill at doing that, that would be really cool. Not required, but really cool. Your material list, and that should be fully filled out and everything in there. And you're going to need, you've got an input shaft, output shaft, a transfer shaft, and you can put on your 4140 steel again if you'd like to keep using the same one. A brass or a bronze would be maybe even better. And then of course you're going to have your plastic. So I'll describe that a little bit more later on. Your design review, that's a formal design review where you have to have documented output. So I want to see that, and it can be a bunch of pages or snips, and it's of your work. And then of course here is your report, your executive summary report information. Really, it's your certification here and here. Okay, and in addition, all of your Excel files, IPT files, IDW files, STL files, all get submitted to Canvas, and they should be organized in a Google Drive somewhere. So there we go. That gives you the what to do for week 3. I think it's a little faster than last week. I strongly suggest that you look this over and get a list of what you do know and what you don't know so that you can prepare a list of questions for the lab session or for an individual meet. Remember, I answer emails predominantly between 8 a.m. on Monday, 8 a.m. to 5 p.m., Monday through Friday. And my weekends are not scheduled for teaching and answering questions. I know some of you, that's when you have to do your work. But if you can do a review ahead of time and have a list of questions that I can answer during the week, that would be ideal. Okay, so do your best at that if you possibly can. I know that's a hardship for some, but I am not a 24/7 resource for you. I'm an 8 to 5 Monday through Friday resource. All right, so I hope that answers some questions and gives you some insight for what to do in Design 330, Week 3, where we're working on our gearbox design and doing the shaft design.